Robots come in a variety of forms and sizes. The ones that resemble us, humans, are likely the most fascinating, appealing, and acceptable. Humanoid robots are utilized in a variety of applications, including research and space exploration, personal support and caregiving, education and entertainment, search and rescue, manufacturing and maintenance, public relations, and healthcare. Recently, blockbuster films and franchises starring robots such as Star Wars, Terminator, Ex Machina. However, fictional robots aren't the only humanoid machines earning money. Real-world robots created by tech businesses are also capitalizing on our fascination with robotics. According to BCC research, the humanoid robot industry will grow from $2.1 billion in 2020 to $7.9 billion in 2025. Researchers are seeking to imbue robots with the ability to detect and perceive temperature changes, as well as emotional quotients and other capacities. They're also developing artificial skin to help robots grasp touch, temperature change, and other sensations. Japan and China are the main countries which are advancing in the field of robots. USA also enters in this field and produces some very fascinating robots. Today we will see some of the robots created by the USA. First robot is the Nimbus. Navoa Incorporated, a healthcare technology firm located in Gilbert, Arizona, today announced the release of the second iteration of Nimbus, an automated disinfection robot. The newest innovation in disinfecting technology illustrates Navoa's commitment to developing technology-based solutions that automate disinfection in healthcare for better and more consistent results and outcomes. According to Ernest Cunningham, president of Navoa Incorporated, healthcare institutions around the country are going above and beyond the status to achieve greater disinfection by adopting technology. Navoa continues to help the healthcare community via the advancement of our own products by providing better, smaller, quicker, and more efficient automated solutions. Nimbus, Navoa's main product, is a robot that atomizes a hospital-grade EPA-registered disinfectant into a dense fog in an empty room. The disinfectant disinfects the air as well as the surfaces in the room. The Nimbus's quick dehumidification procedure eliminates any residual disinfection solution immediately, allowing for instant room return. The method is 99.99% effective against microorganisms that cause healthcare-associated infections, HAIs, and is 300 times more effective than manual cleaning alone. It has also been demonstrated that automating the disinfection process may cut labor by up to 64%, allowing EVS workers to focus on other activities. The new Nimbus machine will be unveiled on June 13th at the Association for Professionals in Infection Control and Epidemiology annual meeting in Indianapolis. Many companies, hospitals, schools, and other public places are resorting to disinfection robots to reopen in the aftermath of the new coronavirus. Several such robots utilize UV light, but Navoa Life Sciences Holdings Incorporated revealed Nimbus this week, a device it claims offers a new approach to killing bacteria that cause healthcare-associated illnesses, or HAIs. The Nimbus robot was created exclusively for patient rooms, according to Navoa. The business stated that it wished to address the issues that healthcare institutions experienced during the COVID-19 pandemic. Nimbus Plus Microburst uses a hospital-grade disinfection solution that has been registered with the United States Environmental Protection Agency. Now we will talk about Cassie. Cassie was created by robotics professor Jonathan Hurst with a $1 million grant from the Defense Advanced Research Projects Agency, or DARPA. Since Cassie's debut in 2017, OSU students funding from the National Science Foundation and the DARPA Machine Common Sense program have been investigating machine learning options for the robot in partnership with artificial intelligence professor Alan Fern. Cassie, the first bipedal robot to use machine learning to control a running gait on outdoor terrain, ran the 5K on the Oregon State University campus, detached and on a single battery charge. The Dynamics Robotics Laboratory students at the OSU College of Engineering merged experience from biomechanics and existing robot control techniques with new machine learning capabilities, said Hurst, who co-founded Agility in 2017. This sort of comprehensive approach will promote animal-like levels of performance. It's quite thrilling. Cassie, who has ostrich-like knees, taught itself to run using a deep reinforcement learning system. Running necessitates dynamic balancing, the capacity to retain balance while changing postures or otherwise moving, and Cassie has learned to make infinitely small changes to stay upright while running. Because of how it was conceived and developed, Cassie is a really efficient robot, and we were really able to approach the boundaries of the technology and show what it can accomplish, said Jeremy Dow, a PhD student in the Dynamic Robotics Laboratory. Deep reinforcement learning is a strong AI technology that opens up abilities like sprinting, skipping, and walking up and down stairs, said Yesh Godse, a lab undergraduate. Hurst believes that, like the vehicle, walking robots will become commonplace in the future. The science and knowledge of legged mobility have been the limiting factors, but research at Oregon State has permitted several advancements. The Dynamic Robotics Laboratory's Atreus was the first robot to replicate human walking gait dynamics. Cassie was next, followed by Agility's humanoid robot Digit. In the not-too-distant future, Hurst said, everyone will see and interact with robots in many locations in their everyday lives. Robots that work alongside humans and improve our quality of life. Bipedal robots will someday have the intelligence and safety skills to serve people in their own homes, in addition to logistical duties like package delivery, according to Hurst. Cassie's final time of 53 minutes, 3 seconds throughout the 5K included around 6 minutes and a half of resets due to 2 falls. One due to an overheated computer, and the other because the robot was instructed to complete a turn at too high a speed. Cassie has mastered the art of going up and down stairs as part of another endeavor. Hurst and colleagues were invited to give a presentation on the subject at the Robotics, Science and Systems Conference, which takes place July 12th to 16th. The robot can work both outside and inside structures, and it has whole-body dynamic balance. Atlas can detect obstacles and navigate tough terrain automatically or by teleoperation. The robot is both electrically and hydraulically operated. Our next USA robot is Atlas. Atlas hardware uses 3D printing to save weight and space, resulting in a small robot with a high strength-to-weight ratio and a broad workspace. Atlas can handle things in its surroundings and traverse over uneven terrain thanks to stereo vision, range sensing, and other sensors. Atlas also maintains its equilibrium when jostled or pushed, and it can get back up if it falls. Growth and learning occur concurrently in both animals and humans. As your body and brain grow, you learn to crawl, stand, walk, run, leap, and participate in sports. However, growing robots is impossible. Robotics engineers begin with a fully developed robot and must teach it all of the skills required to efficiently use its body. Engineers in robotics, like those in many other branches of research, look for ways to avoid copying nature in its entirety by taking shortcuts, building models, and optimizing towards goals. In the instance of Atlas, Boston Dynamics engineers and scientists think that turning the robot for parkour performance will allow them to attain all of the intricacies of bipedal motor abilities. According to Boston Dynamics' blog article, a robot's ability to do a backflip may never be viable in a commercial context. But it doesn't take much imagination or industry understanding to realize why Atlas should be able to do the same range of movements and physical jobs as people. If robots can someday respond to their environments with the same dexterity as the average adult human, the possibilities for applications are nearly unlimited. So the fundamental assumption is that if you can teach a robot to do backflips, jump across platforms, vault over barriers, and sprint on extremely tight roads, you have taught it all of the other basic movements and physical skills that all humans possess. Atlas's development has been nothing short of remarkable. Aside from the spectacular acrobatics, it demonstrates some extremely fascinating foundational abilities, such as correcting its equilibrium after landing awkwardly, according to Boston Dynamics. The engineers were also able to generalize Atlas's behavior by giving it a set of template behaviors like jumping and vaulting, and allowing it to alter those behaviors to new settings it meets. This brings us to the end of our video. Don't forget to like and subscribe to this channel.